Welcome aboard to the Google Cloud Platform for Amazon Web Services professionals. This course was designed specifically for folks that are enabled in Amazon Web Services. If you've been working with AWS services, this course could be for you to get enabled in Google Cloud Platform. As an AWS professional and a Google Cloud professional, I'm really excited to get you up to par in Google Cloud Platform. Google Cloud is expanding its market reach and is becoming a dominant player in some of the industries that you may be working in. As an AWS professional, having another cert like Google Cloud could really enable you to get ahead of your competition. My goal throughout this course is to compare how you're doing things in AWS and how they're done in Google Cloud. We're going to compare and contrast terminology, data services, and we're going to really focus on compute, networking, DevOps, and other facets such as data services to help enable you understand what exactly is Deployment Manager and how is it close to CloudFormation, but what are the differences? What is easier to do on Google Cloud than it is in AWS? But I'll also be honest with you and tell you that some things are just hotter on Google than they are on AWS. As a certified professional in both architectures, I can tell you right now that Google Cloud is really taking off, and I'm really excited that you're going to get on board the course and learn more about Google Cloud. Let's go ahead and get started and join the course. I hope to see you there soon. Welcome to GCP for AWS professionals. In this course, we're going to be talking about Google Cloud Platform, specifically for folks that are knowledgeable in AWS. This course was designed specifically for professionals that have AWS experience. Let me tell you about myself before we get started. I've been working in IT for over 20 plus years. I've been also very interested and active in both the cloud computing and blockchain as a service communities for several years as well. I'm also certified in many areas such as blockchain architecture, cloud computing such as Google Cloud, AWS, certified by VMware, Brocade and Hitachi, and EMC. Just to name a few. I'm also a CompTIA subject matter expert in cloud as well. I've had the opportunity to write exams for CompTIA, specifically the CompTIA Cloud Plus and Cloud Essentials. Let's go ahead and get started. During this course, the objectives are as follows. We're going to go ahead and talk about GCP services and solutions. We're going to walk you through designing a cloud service. We're going to compare Google Cloud to AWS. And we're going to do quite a bit of demos and walkthroughs. The major services we're going to focus on will be networking, compute, storage, data services, security, and DevOps. Now, what I'm going to do is I'm going to compare through charts as well as some demos, the differences between GCP and AWS, but also not just the differences, but similarities. And contrary to what you might think, there's a lot of similarities in how things are implemented and done. On the other hand, there are some clearly different ways of doing business when it comes to Google Cloud as we compare it to AWS. We're going to cover essentially what is generally going to be approximately 6 days of training in under 8 hours. This is quite a feat, but I want to give you as much effort as I can to get you as familiar with Google Cloud so that you know where to go next to learn more. Let's go ahead and get started. We have a lot to cover. Please do download the course materials. It's over 300 pages for you to review and learn Google Cloud. This is a lot of material for a course that's an online format. With that said, feel free to download the PDF. Go ahead and click the link below, and I hope to see you in the next module. Why choose Google Cloud Platform? That's a really good question. And I have some really good insight into why you may want to choose Google Cloud over AWS or any other cloud provider in some cases. So let's go ahead and proceed and talk more about it. When it comes to Google Platform, Google has literally the most powerful infrastructure and they own most of it. This is clearly documented in numerous white papers, analyst papers. So that's not really something that's really disputed. But one of the things to point out is when you're using Google Cloud Platform, if you're using the services like Compute Engine to other services in Google Cloud, you're going over Google's backbone. Now, this is again a big deal from a latency and performance perspective, and also possibly security as well. We're going to talk more about that. Google owns their data centers, and matter of fact, Google's been in the data center business for quite longer than the competitors, so they know data centers. They also have an extensive fiber backbone, and if you go to peering.google.com, you'll find out more, and we'll cover that during the remainder of this chapter as well. They also have submarine lines. They're the only major cloud provider that has submarine lines. Also, too, they have points of presence, and they utilize them actually in a different manner than a lot of other cloud providers as well. So let's talk more about it. But before we get into some of the technicals, let's just talk about, for example, how Google Cloud looks at their cloud platform. Now, this is the original Google Cloud platform, at least from a few years ago, that they used to market their platform as. Really, they were focused on developers building and testing and deploying applications. That was sort of their marketing motto. Now, of course, that's changed now, but in general, they've really prided themselves to be very technical and very scalable as well. When it comes to analytics and mobile and back-end machine learning, etc., Google has some amazing solutions in those areas. Not that other providers don't, but depending on what you're doing or how you want to do it, you may want to look at Google Cloud Platform. Google provides interoperability at multiple layers of the stack. And what this means is that you can essentially be as granular in your programming of your application as you pretty much can to help alleviate a lot of the performance issues, for example, or even address security on different layers of the stack. Kubernetes engine. Now, Google was literally the developer of Kubernetes, and therefore they really have an upper hand when it comes to containers. Now, when I'm talking about container engine, which is now actually Kubernetes engine, they have the ability to deploy services in multiple ways. And we'll go ahead and talk more about that when we get to the DevOps part of the course. And also the compute engine part of the course as well. Can leverage multiple providers. For example, you have the ability to go on-prem or over to AWS, especially like if you want to use Stackdriver. There's a hybrid monitoring solution called Stackdriver we'll talk about. Google supports open APIs, which, for example, AWS does not, especially if you're looking at deploying a cloud endpoint. We're going to talk more about that in the DevOps part of the course. Let's talk about financing, or let's talk about the cost of doing business. Google clearly has, in my opinion, pretty unique approach to pricing. Now, I'll be honest, the other competitors have caught up, but when it comes to sub-minute billing, Google bills essentially in what's called multi-level or minute-level increments. Now, there's, of course, you only pay for the time that you use. And another thing to point out as well is that you get discounted prices as long as you're running the workloads. And what's also cool when we get to the virtual machine pricing part of the course, you'll find out that the sustained use discounts are given to you automatically. In other words, there's nothing you have to do, and I'll talk about how that's structured. Another area of pricing is that you don't have to go out like in Amazon if you want to get a reserved instance, and I'll talk about the comparable in Google Cloud, how that works. But if you want to do a 3-year term with Google, you'll get the price for the 3-year term, and you don't have to prepay like you do in most of the other cloud providers, for example. In AWS, you get a prepay for that 3-year term. So this is a big deal when it comes to saving CapEx or even OpEx, depending on how your company is funding this cloud. When it comes to Google versus AWS, generally, and there's a lot of good information on this. Couple good blog posts you can look at is from Kinsta or from RightScale. They have really detailed pricing structures, and Google Cloud comes out ahead most of the time. When it comes to IOPS, Google blows the competitors away, at least at the time of writing. I won't get into the details. There's plenty of documentation on this, comparing AWS to GCP with the number of CPUs and RAM and, using block storage, etc. And the cost could be 3 times the difference. When it comes to services, a lot of the services in Google are global. They're global scale because Google uses a different approach to networking than a lot of other providers. They have essentially their own customized version of software-defined networking. I believe it's called Andromoto, and I know I'm not totally saying that right, but again, you can look into that. There's good white papers on that. But basically, what this does is it allows you as a customer, for example, in AWS, you don't have to, be too concerned about like deploying your virtual machines because you know that they're regional. In Google Cloud, this is a global effort, and we'll talk about that more in detail when it comes to deploying compute services in Google Cloud. The networking in Google is essentially global, and this is a big deal. It's really, in my opinion, a huge differentiator compared to the other providers. Also, too, you have for example, a comparison here that I guess I could talk about as well is in Google, the VMs and Compute Engine are global. We know that. But in AWS and EC2, they're more isolated. So you're limited to how you could move your services around, and this could be a big deal in the right use case. You have the choice of managed and unmanaged services. Again, in Google Cloud, a lot of the services that are not managed in AWS are managed in Google Cloud with no additional cost to you in most cases. For example, DNS is a great example. Load balancing is another example. There's a lot to talk about during the course to give you an idea of what Google is doing better than some other competitors. But I also, when I talk about network, compute, services, DevOps, I like to point out not only what Google does right, but what Amazon does right as well, and let you figure out which way makes sense. I'm not here promoting one over the other because I make money teaching both. So I'm sort of unbiased, to be honest. I like to have the best competitor win in the right use case. Now, Google Cloud has some really unique benefits when it comes to security or data analytics, machine learning, and AI. We could talk for hours about data services or AI or ML, but we won't do that for this course. That's another course in itself, literally. But I want to touch on, for example, when it comes to serverless computing, using Lambda is really a great solution in AWS, but you could use cloud functions as well in Google. And Google really does have some great leadership in microservices and serverless capabilities. We'll talk about that when we get to that section. Now, when it comes to security, this is sort of important to understand. And there's a really good white paper you want to look at. It's called the Google Security White Paper. It goes into how Google handles basically security. They have I think it's at least 400 or 500 security professionals in the back end just dealing with Google security. Basically, everything's encrypted in transit between Google, the customer, and the data center. And also all the services. Basically, everything's stored on persistent disks. It's all encrypted. You can either let Google handle your keys or you can handle them. It's up to you. Google, like we had talked about, addresses the stack differently than other providers. So you could go in and modify the storage stack, for example, and determine how you want to address authentication or authorization if you so choose. When it comes to security certifications, auditing, they do have some good benefits there. But to be honest, AWS is clearly the leader in compliance when it comes to a lot of the worldwide requirements. No doubt about that. When it comes to, for example, in Google, you can tie in to G Suite or Gmail. This is really amazing for customers already using G Suite because of the fact you could really integrate your current lifecycle into Google Cloud. So really awesome stuff with security going on. I'm going to touch on some more of this during the course as well. Let's talk about some more technical benefits to give you an idea where we're going to go in the class. You have the ability for live migration. In other words, Google has the ability to handle migrating your VMs, and you could migrate your own VMs as well on the fly. You have a lot of capability there. So if there's an issue going on, you can move them and you don't have to shut down that VM. Also, too, persistent disks. One of the challenges when you attach a disk is if you resize it in other vendors, you have to do what? You literally have to unattach it and start over. That's not something that you want to do or ruin a weekend over if you don't have to. Google lets you do this on the fly. Load times. There's a couple good white papers that you could go ahead and look at when it comes to performance. You have the ability to really scale up your IOPS, but also to increase, or actually I should say decrease your load time. And again, if you're looking at performance requirements, you could certainly check out some benchmarks that was done by a company called Kinstide. Check them out as well. Now, tiered networks, we're going to talk more about that a couple times during the course because this is increasingly becoming a differentiator for a lot of my customers and students as well, because of the fact that Google offers 2 tiers to their networking, and I'll talk about what that is. But essentially, if you want to pay more, you can get more and literally traverse over Google's own network when it comes to you wanting to deploy some of your services. We'll talk about that. Now, there's 2 tiers, right? There's standard tier and premium tier. Basically, you could have your traffic over Google's well-provisioned, low-latency, highly reliable global network. It's fully redundant, at least with 3 paths, that is. Supports N+2 redundancy, essentially, right? And if you want to go between 2 locations, you can certainly do that. Or if you don't want to pay for the premium tier, then you could certainly use a standard tier, which you're essentially traversing the internet to go from one cloud platform to another cloud platform in Google. Now, when it comes to standard or premium tier, basically this is an example of premium tier. The link for this blog post goes into really good detail. For time purposes for this course, we won't cover this in real deep detail, but when we get to networking, I'll cover just a touch more for those that want to know more. But one of the things when you're architecting a cloud solution, if you have a production app that is really latency sensitive, this may make sense to use. So essentially over here to the left, you're going from one GCP region to essentially a provider that supports the premium tier. In other words, as partners. So basically, again, you could go ahead and go directly over Google's network to the point of presence, to your service provider, to the end user. Now, what about if you want to go to another cloud platform region? And again, you don't have to, totally go through the internet and induce additional latency if you want to go from one GCP region to another. So that's, again, more detail in this blog post here. I would check it out if you're interested. Now, here's the number of zones and regions. We're going to talk more about that. I have a section just on zones and regions. Now, Google, AWS, to be honest, they're very similarly dispersed from a geographic perspective. There's no major differentiators there. Perhaps you might want to have a cloud provider that's in Montreal. Well, Google would be the choice maybe. Once again, check out the link here for additional current up-to-date information. Submarine lines. Google owns the network. In other words, these submarine lines Google owns. They may lease part of that with the governments, for example, or other telecom providers, but they have submarine lines in most cases. And what I'm trying to get at is there isn't really another cloud provider that can say this. So if you're going from Charleston to Finland, it could be more efficient to go over Google's network than to go over your internet provider. These are things you want to look at. And here are the regions and zones. We're going to talk more about this in the next module, so I'll hold off on that, but you can see it's pretty darn similar to AWS from a numbers perspective. Let's do a quick review before we close out the module. We know that Google has the most powerful infrastructure and they own it. They don't lease most of it, they own it. Google has an impressive compute engine cost efficiency. Remember that there's different tiers. You don't have to prepay for your instances that you want to get the savings on. I'll talk about more in the compute part of the course, especially around the types of instances that are available, types of discounts that are available, what would be the comparable spot instance that AWS has to what Google has. So we'll talk about that more in the compute part. Google has VM Live Migrate. This can save your cloud deployment from being down and also gives you flexibility in how you want to deploy your services as well. And Google, we know, has a network tier that's premium and allows you to deliver your traffic over Google's well-provisioned, low latency, highly reliable global network. Okay, so we have a lot to cover. Let's continue on. In this module here, let's compare infrastructure and talk about regions and zones. Now, when it comes to regions and zones, essentially they're pretty much what you would expect. But before we get started, I want to talk about some terminology that generally is comparable, but also different at the same time. And then I'll talk about what the main differences are between AWS and GCP and how they implement their services. Now, we have AWS. Their idea of a region is really called global infrastructure. Google Cloud breaks it down into regions and zones, but in reality, it's really the same thing. When it comes to an abstracted data center, that's a zone. And a zone is exactly what you would think it is in the world of AWS. And it's really the same in Google Cloud. Now, let's just talk about some of the differences here. The main difference is going to be around caching, and AWS names their edge caching CloudFront. Now, Google uses Cloud CDN. Again, at a high level, it's caching. However, there's a lot of significant differences in Google. For example, Google and Amazon do have quite a bit of edge locations. However, they're definitely approached differently. Amazon generally uses them as a CDN, and that, of course, is called CloudFront. And the goal of that CloudFront is to cache that static content to the user base. Now, with Google, basically, they also use them for caching, but they're also points of presence as well. And one of the differences is that around, for example, Cloud CDN, is that it's directly connected to Google's backbone, basically. Now, Google has, we know, a fiber backbone from the original first module. We know that Google owns their infrastructure. We know that Google controls it. When you connect to Cloud CDN or an edge, you're connecting directly to Google's backbone in most of the cases. Now, this provides a lot of value from a latency and performance, but also security standpoint as well. Google has been investing in their networks for quite a while, for over 15, 16 years at least. And they have the most extensive network. We know that as well. But basically the POPs, for example, when you think about it from an edge point of view, these are going to be very unique from a cloud vendor perspective. Essentially, instead of you going out and depending on like your cloud provider like AT&T, Unisys, British Telecom, whoever it is, you're essentially going directly to Google's backbone, and therefore you're connecting to other Google Cloud regions directly over the backbone. So this could be a big benefit. Now, Google's network, of course, has well over 100 plus POPs. They're in, I think, 36 countries now. You get the lowest latency, and your costs are also lower too, generally. So you essentially can peer directly with Google. So this is a big deal. And there's also, of course, Cloud Interconnect, which I'll talk about shortly as well. When it comes to backbones, Google and AWS have a different approach, and I sort of covered it already. Google's approach to a backbone is actually a backbone directly to their own data centers and regions and zones. You're going directly over Google's own infrastructure. When it comes to data centers, generally region and availability zones are used, and Google uses regions and zones. There isn't a big differentiator between like the way the data centers are. They're both redundant. They're both, isolated as you would expect. The main difference is really in the edge locations. Again, we know that there's 75 plus with CloudFront, over 110 with Google Cloud. Now, let's talk about regions, for example, and zones. Google has over 18 regions at the time of writing, 20 regions for AWS. I think it's, this is a moving target with the providers. At the time of writing, that's the numbers. By the time you may read this 6 months down the road or a year, it may be a little bit more. So don't take those numbers literally. It's just a moving target. When it comes to abstracted data centers, AWS, availability zone, and Google is a zone. Edge caching, we know as well, POP supported. One of the big differences, of course, we've talked about that. It connects directly to Google's backbone fiber. And we know that Google has submarine lines as well. So when you're connecting from Europe and going to the US, you're literally going over Google's submarine lines. Now, total services is here. There's no question, though, AWS is a leader in the number of services and will be for quite a while. Now, when we talk about resources and how they're organized, we know, for example, that when it comes to resources in Google Cloud, that you typically place those resources under a project, and that project is going to be, located wherever you again, want to assign those resources. So just think about the resources you could assign wherever you want under a project. So you're not limited to essentially a geolocation in a project. When you select a region, you're selecting basically where you want to run those resources. We'll go to a demo. I'll show you, for example, in Compute Engine how that works. You're connected by Google's global and meshed backbone. The zones are essentially isolated deployments. Once again, just think about it from this perspective. An AWS is an availability zone, and Google, we call it a zone. So resources can be zonal, regional, or multi-regional. As you would expect, the zones are high bandwidth, low latency network connections to other zones in the same region. We'll go ahead and talk more about those zones and regions here in a second on the next page. But the goal is to help you mitigate your bandwidth costs between regions and zones as well. And as you would expect, having redundancy, having your applications across multiple zones and multiple regions is recommended. And again, that's a AWS recommended best practice. Again, like with the S3 outage that they had back about a year and a half ago in Northern Virginia. Again, if you're a customer that didn't have redundancy, you really, again, shouldn't expect to be up if that data center or that availability zone went down. All right. And again, same approach here. Google's recommending redundancy. All right, so this is essentially a map of, basically a graphic that shows the regions and zones in Google Cloud. I won't, of course, read them all to you. I'll let you figure that out, what makes sense. But basically, one of the things that Google does is they don't deploy a region without at least redundant zones. So that's not going to happen. And as you see, they have at least 3 zones in each of the regions. That's usually the minimum that you see in most cases, with the exception of Europe and Asia and one of one of the zones, again, but one of the things about Google, they're just deploying this redundant, but over time, they're going to likely add another zone anyways to that region. Now, AWS as well, again, they have different regions and zones. Basically, Google has 18 plus regions, 55 zones, or actually more than that now, over 100 plus points of presence across 35 countries. And they have hundreds of thousands of miles of fiber optic cable going between the continents. And here's a comparison of AWS. They have 20 regions and 60 availability zones. Now, the real differentiator, though, when it comes to AWS and Google is going to be in the government sector. There is no question AWS is well ahead of Google when it comes to FedRAMP support. Now, for my friends that are overseas that are not in the US and not familiar with FedRAMP, basically our federal government mandates that government agencies have specific compliance requirements, and to be able to maintain that, there's FedRAMP policies and procedures and best practices that have been put out. Basically, it's a term that is used. Basically, it's the federal government's approach to deploying cloud services. So a little bit more than that. Again, that's another discussion, but I just from that perspective, if you haven't heard of FedRAMP, then, don't be surprised. But this is more for our federal government customers in the U.S. Now, this website is where you want to go. It's called peering.google.com. And go there and just take a look and understand how Google's infrastructure is actually laid out. This has a really good approach, in my opinion, to explaining to you how Google approaches their data centers and their POPs and cache locations. If you go over here, for example, this is again showing you their data center locations. Go down here, this is their edge locations, and then if you scroll down even more, this is again their additional edge nodes, etc. You can see that it's pretty well documented in this case. And again, you have different options of connecting. I'll let you figure out what makes sense in your environment. Then if you go over here, go to regions. And this will point out the cloud locations. This, again, at the time of writing, this is what's available. They do have new regions coming in Switzerland, Japan, and Indonesia. This is their current network at the time of writing. One of the things to note is Google, does launch with 2 zones, but they do want to have a minimum of 3 zones. Now, one of the things about services and how they're deployed is some of the services are regional, like App Engine is a regional service. And they're not exactly deployed in every region, and so you need to validate where these are deployed. Most of the services are deployed in every region, with the exception of a few, like App Engine and Cloud Functions, you'll want to pay attention to. And once again, take a look at the services and determine what is the best approach. Now, we will be talking about, for example, in Google Cloud, some big differences in how they implement load balancing as compared to AWS. In Google Cloud, it is a fully managed service and it's a global service. We'll talk more about that. So definitely go over to the location website and also the peering website to get some more information on peering and the locations. Let's go ahead and move on to the next module. In this module, let's talk about organizational hierarchy and what a project is in Google Cloud. Now, being that you're familiar with AWS already, you likely know that in AWS, you have an organization. and then you create sub-accounts under that organization for billing purposes. Now, in Google, you essentially create an account and then you provision resources from a project. And I'll explain why this is actually a better solution from a granularity perspective, but there could be advantages, especially if you could create a project and then create separate divisions or groups in your organization. For example, production, development, QA, legal, whatever you want to dream up, and then enable each of the departments to have their own billing and resource management, for example. Or you could turn around and extend this out to your G Suite domain or Gmail and actually take in the life cycle of G Suite as part of your Google Cloud platform. Now, with GCP accounts, you could associate those essentially to G Suite. And when you do that, it allows you to extend that G Suite domain to your cloud services. So what does that do? It allows you to federate G Suite to Google Cloud. And there's a lot of good benefits around that. And one of the benefits is the fact that you could go ahead and take an organization and delegate administration, for example, or billing responsibilities to a project, which would be a department, a division, whatever you want to consider, and allow them to handle everything locally to a degree, but you as the organizational admin have full control over essentially the company resources, basically organizational resources. So again, you could have as little or as much control as you want, and a lot of great benefits to that. Now, when it comes to, for example, a project in GCP, let's think of a project as an organizational sandbox is really sort of a good way to look at it. It allows you to segment resources basically for, and when I say resources, I'm really saying services such as cloud storage or compute engine, and allow you to have separate billing and accounting. Now, each cloud project is going to have a project name, a project ID, and a project number. A project is really meant to track resources, and also as part of a project, you have quota usage as well, which you could track in a different way as well. And then you could enable billing, manage permissions and credentials, and then also when you create a new project, all the services and APIs are under that quota. And this is a really good way to control your spending and not have runaway spending, for example. And this is an example of a project name with a project ID, project number. But basically think of a project as a way to facilitate your services and objects for billing and accounting purposes. Now let's go to a whiteboard and talk more about this so you can see exactly how this comes together. Now, in this whiteboard that I just put up, you can see that I have a domain here, myblockchainexpert.com. And let's say this organization, for example, we'll just take it here. We're already using G Suite. And because we're using G Suite, we want to extend to Google Cloud. Now, what I could do is when I extend to Google Cloud, I could extend out here, here, and here. And basically, I create 3 projects. And each of these projects will have different resources. And also different billing methods. So for example, I could bill dev to a separate credit card and test to another, and then prod to another, or a company PO, whatever is accepted. And with that said, I can go ahead in and have full organizational admin control. Now, Google Cloud calls this an organization. And these levels here are called what? They're called projects. So a project is essentially a sandbox of resources that are being spun up in my account, but they're being basically provisioned by different resources if I so choose. In other words, when I say different resources, I really am inferring that if I have dev resources, I'm spinning up dev resources inside of development, and then test, and then production. What's also cool is, let's say, for example, here, I want to have development, test, and production as separate organizations, but I want to bring them together as well and create what's called a pipeline, like a CI or CD pipeline. Well, I could simply do that by peering them over if I want. And this is, again, a great benefit of Google Cloud. It gives me as much isolation or as much basically comprehensive organizational structure as I prefer as well. So with that said, I could have segmentation, or I don't need to have segmentation. So this is a project at a high level. What I'd like you to just take out of this is to understand that an organizational unit and an organization in Google Cloud is slightly different, and that a project is really similar to a sub-billing account essentially in AWS. But there's some better benefits such as isolation, separate billing means, but also integrating into G Suite as well. So for example, if I wanted to, again, I could tie into G Suite if I so choose. Let's go ahead and move on. So a project has basically three parts to the name. We know that. We have a name, a project ID, and a project number. The project name is for you to identify what it is, just visually, so that you know it's for development, or you know if it's for production, or it's located in Boston for resources, or for resources in Singapore. My project ID is going to be for a service account identification, essentially, and also how you can integrate with other Google services. And then the project number is how Google references your sandbox of resources in the back end. You can change the project name and the project ID at the time of creating the project. However, the project ID is not going to be able to be changed after you create the project, but you could always change the project name. The project number is not something you could change. That's identified by Google. And then we have folders. This is an extension of identity and access management. You create policies, and it gives you additional layers of granularity. For example, Google Cloud IAM is comparable to AWS Directory Services. So you can think of a similarity there. Now, with GCP, there's 4 layers in the hierarchy. We have an organization, we have folders, project, and then resources. Think about it from that perspective. Now, the organization is known as an organizational node when you create it. The folders are an extension of IAM. You don't have to create folders if you don't want to. It just gives you that granularity if you so choose. And then a project, we know what that is. And then the resources are going to be under the project, which is going to be what? Your virtual machines, your storage, Cloud SQL services, APIs, etc. And here's an example of a project hierarchy. You could have, for example, your admin project, here, a team project over here with different resources, and you could push them out or not. It's up to you on how you want to structure this. And Google, an organizational resource, is available for G Suite and Cloud Identity. Now, we'll talk about what Cloud Identity is, but essentially Cloud Identity is identity as a service. It's a software as a service. It allows you to extend it allows you to create basically lifecycle as part of a software as a service solution without having to use G Suite. You could also link your domain to G Suite as well. Think of the organization as a hierarchy. It's a top level. You set your access control and configuration settings at the org level or the project level. Remember the whiteboard, we could choose to have full control at the org or delegate it to the project. What is really a big deal here is that, especially like if you're in a dynamic organization with a lot of people coming and going, then you may need to have some kind of life cycle as part of your corporate cloud structure. And again, if someone leaves, you just simply delete resources, move them to another user or archive them, whatever you want to do. A lot of flexibility there. This is, of course, useful because you follow a life cycle with your Gmail and G Suite. Basically, one of the challenges that I found in a lot of organizations is that HR is really good at letting you know, like the email administrators know that so-and-so left the company, but that's only the email administrator. What about the cloud administrator? What about the Salesforce administrators, etc.? And if you create a life cycle as part of your corporate IT lifecycle structure, then great, do that. And this enables you to do that. Now let's talk about some concepts and terminology, essentially. In AWS, you could have essentially one billing account. GCP, you could have several per account or many. With a billing structure in AWS, we would call it essentially a sub-account. In GCP, we call it a project. Now the roles are going to be IAM user groups or roles. In Google, basically, you could also have the same, but you could also extend it out to Google user and groups as well. AWS, it's a root account. In GCP, you could have the G Suite account extend out. That would be also called an organizational admin as well. Now, APIs are going to interact with project-based resources. When you spin up APIs, these are essentially spun up per project, per resource when you spin them up. So for example, if you're not using Cloud SQL or you're not using Cloud Data Store or Cloud Storage, then the APIs are not spun up until those are provisioned. Now, resources in GCP are global, regional, or zonal. This means, for example, if I have a virtual machine instance and it's attached to basically a zonal resource, then I can't just move that around. It's a zonal resource. But if that image is not attached to a VM, then I can move that image where I need to be. And one thing to point out too is that global resources are used by any resource that can be moved around. Regional are only in that region. We'll talk about what regions and zones are here shortly, very similar to AWS. Now, in GCP, you can, of course, link your G Suite. We already, just a refresher here, know this. You could take your G Suite domain and extend it out. They're basically an administrator domain. Link your G Suite however you want. So the key takeaway here is really just the fact that the differentiators with Google is that you could have multiple billing accounts. You group the projects however you like, and then have a hierarchy that's essentially going to be a super user, like G Suite super user. So once again, this is the main takeaway here. Now, when it comes to quotas, each project has quotas. You have free quotas that are essentially for a free account, and then you get different levels of paid resource quotas as well. The goal is to limit the number of resources created, but also, too, you can increase the quota limits based on the requirements of your account. Google does this because of the fact that they don't want to see resources spun up that aren't needed by accident, but also, too, it helps mitigate performance issues, but also mitigates billing issues down the road for the company and Google. With that said, quotas are essentially going to be an important part of a project. Now, let's go ahead and go over to the project demo. I'm over here at the Cloud Console and Google Cloud Platform. If you haven't signed up for a free trial or free tier, I encourage you to do that. But what I like to do right now is just show you how to create a project. You simply log in. Once you're logged in, you go over here to project settings, or you go up here and select project just to validate what you have. I have one project. I want to go here and create a new project. Now, it's telling me because I have quotas, just like everyone else. Now, this is a paid account, and because of the number of projects I have deployed, I only have 16 projects left. The default with a paid account is 20 or 21 at the time of writing. I'm not sure what it may be by the time you use it, but about 20 or 21 is what I've usually seen. Now, I'm going to call this test project 1, and it's telling me that it looks okay, because if that was a conflict, will let me know. And then I could also go over here and change the project as well, the project ID. Now, this is going to be for my service accounts. If for some reason I want something easy to remember, I could try to change it. I could also have Google give me ideas as well, as you see. Whatever I want to call it. This is mainly for the service accounts and for your resources. Now, if I had G Suite tied in, it would populate and allow me to tie it to an organization. Now, because I don't have an organization in this setup, I'm going to default to a project. So I'm going to go ahead and create this project. That's going to be my top tier. So it'll go ahead and create the project, and we'll go back and check on it. And I'm going to go up here and check now, and you can see that my test project is there. Now, just take a look. You can see that there's no resources in it. Nothing going on from that perspective. But if I go back to the original project, you can see that I had App Engine and some storage buckets that were running at the time. And again, I could change my billing. You can see my billing is $1.49. If I go back to this project, you can see that there's no billing. This is essentially how you create a project. We'll do a lot more around projects and resources throughout the course. Let's go ahead and move on.